Okay, so if you want to write a definition for a piecewise defined function, all of this is the function f of x, but it's doing different things with different sections of input. So the first thing I'm going to do is take stock of the different sets of input I want to consider in different ways. So I notice that I've got three sections of the graph. I have values of x that are, let's see, values of x that are less than or equal to -2. So that's going to be the first section of my graph. So it's going to do something with values of x that are less than or equal to -2. And then I notice it's doing something different from -2 all the way up to 1. So I'm going to have another section for -2 is less than x is less than or equal to 1. And then lastly, I've already covered 1 itself. So basically once I pass 1 and then all the way up to 5, that's a different set of stuff happening. So I'm going to say that is for 1 is less than x is less than or equal to 5. Okay, so all you really have to do to be successful writing a definition for a piecewise defined function is understand what is happening in each section of the graph. So, for instance, on the far left side, clearly we have a linear function. This linear function right now doesn't have a y-intercept, but I'm going to sort of continue the relationship just to figure out, oh, where would the y-intercept for that be? So I can tell that if this pattern continued, I'd go up 2 over 1, up 2 over 1. Oh, so this would be the y-intercept. So like really this is the graph of y equals 2x plus 9. It's just only being considered back behind -2 and included. So I'm going to say, okay, for this section, what this function outputs is 2x plus 9. So for any value of x that's less than or equal to -2, when you plug that in, all that happens is it gets doubled and we add 9 to it. Check. The next section is really easy. On this section, our function is exclusively shooting out 8, right? It is the horizontal line y equals 8. Output from this function is simply 8 for this set of input. And then lastly, I've got a parabola here. It's clearly got an over 1, up 1, over 2, up 4 pattern. So I'm pretty confident that it's just got an a value of 1. So I can just do this in vertex form. This has a vertex at 3, 4. So I can just say that for that section, I've got x minus 3 squared plus 4 as the input-output relationship. All right? I looked at separate pieces. I set up the separate categories that input would be considered in. And then I found the equation for each of those different pieces and defined that here. That's all you need to do to write an equation for a piecewise defined function. And if I wanted to evaluate something, for instance, let's say someone had asked of me, what is f of 3? The idea is this input is going to fall into one of these categories. Clearly 3 is not less than or equal to -2. It's not between -2 and 1. 3 falls into this category, which means this is the output definition. To get the output for an input of 3, I have 3 minus 3 squared plus 4. Or 0 squared plus 4. The output for an input of 3 should be 4. Let's check. The 1, 2, 3rd gun is indeed shooting out 4. Things are going well.